I'm going to use something that we know very well. Just now we saw this reaction already. Remember? Sodium plus chlorine give you sodium chloride. Remember? Just now when we were talking about group 1. So use something that we know very well. So if I just want to balance it, I think look like this. Make sense? Now, just now we show that sodium has been oxidized. Once again, sodium plus, sodium is 0. All right, then it becomes plus 1. All right, so it has been, once again, oxidized. Then I want to show you what happened to chlorine. Basically, I transfer electron to you, I give you, you take in. I give you, you take in, yeah, correct. So from here, if you take a look, all right, using oxidation state is the easiest to compare, right? Though this is -1, so this has been reduced. Make sense, everyone? It's just a story. Keep it simple, all right? You don't want story, then very difficult to do well for chemistry. You read the books, you can buy all the accessible and popular, you won't master it. All right, it's just a story. Get used to the story and be fine. So chlorine, what happened to chlorine? Ready? So chlorine itself over here itself get reduced. Right? Itself gets reduced or being reduced. All right. So how it get reduced? We learn RIG. Reduction is the gain of electron. Make sense? All right. And it oxidizes others, right? Itself get reduced. It oxidizes other substance, which is sodium in this case. Which means, therefore, is a very good oxidizing agent. Make sense? So if you cannot see, then I show you further why it is a good oxidizing agent, i.e. gain electron and get itself reduced. If you take a look, this is how, for example, chlorine look like. And again, I should go to the equation there and show you what's happening. If you look at chlorine to Cl over here, this is the story. Make sense? Correct enough. Take a good look. What happened to the Cl2? It becomes 2Cl minus. So the electron on the left or on the right? That's another question again. Ta-da! Left side. All right, so that the charge will balance. Can see everyone? So if I color code these two electrons and show what's happening, you will sure get it. All right, so let's use dot and cross. Cl2 molecules based on chemical bonding covalent look like this. Where did the two electrons go? The two electrons were contributed by sodium. Can see? Each sodium has one valence electron, right? 2.8.1, 2.8.1. So that one electron, one of them say, hello, please take over. The other one come here, say, go too far. All right, please take over. Can see now, everyone? Makes sense, huh? It's just a story. It's all bonding. So if we take a look, then your Cl, what happened to it? Your Cl has become Cl minus. Whether it's dot or cross, right? So I just draw like that. If the electron from sodium, I call it a triangle, if you don't mind. It look like this. Can you see, everyone? That's why it becomes what? It becomes Cl minus. And times 2. Make sense? That's all. That's what we are doing. We keep it simple. You gain electron from whoever, in this case, this reaction with sodium. So sodium gives electron to the chlorine. Each of the chlorine atom will take in one electron from the sodium, each. All right, and then form your two chloride ions. And so what I've done over here, I hope, is to share and to convince you that your halogens, your Cl2, your Br2, whatnot, using that equation that we know quite well, is definitely an oxidizing agent. And its job is to give, or rather take electron from others. So that part, be very careful. Okay? Can? Alright, so it's a very good oxidizing agent. When it's an oxidizing agent, it oxidizes others, then we talk about its oxidizing ability, its strength, which is once again linked to its reactivity. It's going to be the same reason. Okay? So let's take a look as we go down group 17, why their reactivity decreases. Why fluorine most reactive, astatine less reactive. Okay, so I need to clear this space. So it all have to do with this, right? So here we go. Since chlorine is there, let me just draw a fluorine on top, right? So fluorine, yay. It's the same reason, my friend. Here we go. So where is, let me use orange color for fluorine. Fluorine atom is what? Is smaller. Am I okay? Smaller. Make sense? Fluorine is smaller. The electrons around it is still the same, yeah? It's still the same. All right, so once again, how we react with, say, sodium, right? So sodium 1, sodium got 1. Its job is to give one electron to here, one electron to the other fluorine. Everyone okay? Correct, everyone. That's how you react, Mark. Done with all. Why the reactivity decrease? Because it happened only when the electrons are stuck here. Make sense? Make sense, everyone? When they become the ions. All right, so if you don't mind, I write the answer, yeah, slowly. My answer, I'll just use the space here if you don't mind, huh? All right. As you go down group 17, what happened? The atoms are smaller. Hey, did I say a bit smaller? They are bigger. Say wrong term. They are bigger, right? They get bigger and bigger. Correct? The valence shell, which is the outermost shell, right, is further away from the positive nucleus. So what? So the added electron, say from sodium in this case, make sense? The added electron is less attracted to the positive nucleus. And therefore, ladies and gentlemen, the reactivity decreases. Because its job is to gain electron ASAP to become ions. But the attraction is lower and lower. So it's the opposite of group 1. Everyone okay? Oh, crap. That's why our hydrogen, our group 17 is always become chloride minus blah, blah, blah. Because that's its job. Can everyone? Make sense? In exam, if you come to this topic, if you are tested on this topic, they will not ask you about reactivity because like that everyone will be very clear. Everyone okay? They will confirm test it this way one. Because you realize here you need to twist and turn your story. Alright? In terms of redox. Okay? Alright. If you learn both topics, they will test it this way. We ask you about the oxidizing power, alright, increases or decreases. So with this discussion, it also shows us that fluorine is more reactive, or rather it's the most reactive. If I just compare these two, this is less reactive. Okay, make sense? If you would like to catch my latest videos, click on subscribe button right now. And click on the bell if you want to receive instant notifications once I've uploaded my latest video. If you would like to join my live chemistry classes and revision workshops, go on to winnerseducation.com and find out how you can score distinction for chemistry on a consistent basis, either in our center or online via Zoom. If you want to check out my online school, go on to passwithdistinction.teachable.com. You'll be able to learn chemistry concepts at your own pace and anywhere in the world, topic by topic. This is Sean Chua from Winners Education, to your distinction in chemistry.